This is the first episode of our new series, My Favorite Dinosaurs, so this should be fun. Hey there, welcome to Dinosaur Train. I'm your host. Today we are taking a trip to Late Cretaceous North America to meet the Ceratopsians. That's right, the horned dinosaurs. The name Ceratopsian comes from the Greek words keras, which means horn, and ops, which means face. And Ceratopsians definitely had faces full of horns. Now, the most famous Ceratopsian is probably the Triceratops. I mean, how could it not be? It has 3 horns on its face, a big frill around its head, and it was one of the last dinosaurs to ever exist. But Triceratops wasn't the only horned dinosaur. In fact, there were many different kinds of Ceratopsians. So today we're going to learn about some of our favorite horned dinosaurs, including the aforementioned Triceratops. So let's start with the basics. Like all dinosaurs, Ceratopsians were reptiles that lived during the Mesozoic era. The first Ceratopsians appeared in the fossil record in the early Late Cretaceous, which is divided into 2 ages, the Santonian and the Campanian. The Santonian began 86 million years ago and lasted 81 million years ago. The Campanian then began 81 million years ago and lasted 72 million years ago. These ages were then followed by the Maastrichtian, which saw the end of the dinosaurs, but more on that later. The Santonian and Campanian were pretty warm ages, but they were also very humid. These conditions allowed lush rainforests to cover much of the land in parts of Asia, Africa, and North America. And it was here, in what is now North America, that the first Ceratopsians evolved, and they did so from a group of herbivorous ornithischians called the Ceratopsians. Now don't worry, I'll stop using these big, scary scientific names in a minute, but I do have to use them in order to accurately describe the evolutionary history of these dinosaurs. I promise I won't use them anymore once we get to the good stuff. Anyway, like other ornithischians, the Ceratopsians were primarily herbivores with beaks and jaws that were great for nipping plants. They also had a distinctive pelvis that had a hole in it, which allowed more flexibility in their hips. This is actually a trait shared between all ornithischians, as well as another major group of dinosaurs known as the theropods. See, when scientists look at the structure of a dinosaur's pelvis, they can tell whether it's an ornithischian or a theropod. If it has a hole in it, it's an ornithischian. If it doesn't, it's a theropod. Theropods include both the herbivorous and carnivorous dinosaurs, so having a hole or not isn't necessarily an indicator of diet. But still, this pelvic feature is a huge help to paleontologists trying to figure out which dinosaurs are related to each other. So far, 13 species of Ceratopsians have been identified and named, and they were all found in western North America. One of those species was the Menifee Triceratops. You may be thinking, wait, you said that the most famous Ceratopsian was the Triceratops, and you just said that this was the Menifee Triceratops. Aren't they the same thing? Well, they're not. The Menifee Triceratops was a relative of the Triceratops that lived before it. You see, the Triceratops itself evolved from earlier horned dinosaurs, just as we all evolved from earlier relatives. As time went on, the lineage leading to the Triceratops eventually gave rise to the species we know as Triceratops horridus, or simply the Triceratops. Both the Menifee Triceratops and the Triceratops lived in what is now North America. But when the Menifee Triceratops lived, North America was connected to Asia via a land bridge. So it's possible that members of both species could have migrated between the 2 continents. Now let's talk about the Triceratops. The name Triceratops means 3-horned face. And of course, it gets this name because of its 3 horns, which grew from above each eye socket. Triceratops also had a large frill made of bony, flexible material attached to the back of its skull. This frill didn't grow out of the same tissue as the rest of the skull. Instead, it was formed from elongated and thickened skin along the back edge of the skull. The purpose of this bony frill remains unknown, though some scientists think it may have helped to support jaw muscles. Some also think it may have played a role in attracting mates. Another theory suggests that the frills were used for display, helping individuals recognize each other. Finally, the frill may have served as a defensive structure, protecting the neck from bites and slashes, while still allowing for flexibility. There are even some scars on the frills of some fossils that seem to show healed injuries. Most of these marks are either nicks or puncture wounds. Triceratops was first described by Edward Drinkercope in 1889. He based his description on a single fossil consisting of a skull and jaw found near the Hell Creek Formation in eastern Montana. Since then, hundreds of Triceratops fossils have been found. Not only are they common in eastern Montana, but also in the Hell Creek Formation in North Dakota and the Lance Formation in Wyoming. A few fossils have even been found in Canada, so clearly these dinosaurs were widespread across what is now the western side of North America. Scientists estimate that they lived during the last 100,000 years of the Campanian Age and into the Maastrichtian. So they were some of the last dinosaurs to ever exist. Also, because of the sheer number of fossils we've found, Triceratops is probably one of the best examples of convergent evolution we have. What's that? Convergent evolution is when two groups of animals independently evolve similar traits. For example, sharks, dolphins, and ichthyosaurs all have streamlined bodies and fins, but they're not closely related. Sharks are fish. Dolphins are mammals. Ichthyosaurs were reptiles. Each of these groups evolved these similar traits independently after spending millions of years living in the same environment. So this shows us that natural selection tends to favor certain traits that allow animals to be better suited to their environment. Okay, now we need to take a little detour to talk about something called ontogeny. That's literally just a big word for development. We'll talk about the development of horned dinosaurs. See, when we study fossils, we try to piece together what life was like when that dino was alive. But sometimes we find that fossils teach us things about evolution that we never expected. And that's the case with horned dinosaurs. For a long time, paleontologists thought that horned dinosaurs developed their horns, frills, and other skull ornaments in two phases. First, they grew a set of small horns on their snouts. Then, later in their lives, they grew larger horns above their eyes. But recent studies of baby horned dinosaur skulls have revealed that they did not have small horns on their snouts. Instead, they had bumps where the horns would later grow. This means that the bumps and the horns aren't the same thing. And this discovery has caused scientists to re-examine what other features may have developed differently as horned dinosaurs grew up. Okay, so let's move on to one of my favorite ceratopsians. This is the Styracosaurus. Styracosaurus is part of a group of ceratopsians known as the Ceratopsidae. The name Ceratopsidae is derived from the Greek words keras again, meaning horn, and ops again, meaning face. But they also added opsis, which means appearance. So this name really means horn face appearance. That sounds weird when you say it like that, but it's true. The ceratopsids were characterized by their horns and frills, which came in all shapes and sizes. The horns could point straight out, or curve out, and even upward. The frills also varied quite a bit. Some were straight, while others were ornate with bumps, cuts, or even spines. Styracosaurus was first described by Henry Fairfield Osborn in 1905. It was named by combining the Greek words styrakos, which means spike or pointed object, and sauros, which again means lizard. Just like the Triceratops, the Styracosaurus was found in western North America, specifically in the genus of Dinosaur Park in Alberta, Canada, and the Hell Creek Formation in Montana. Its nickname is the screw-horned dinosaur because its horns were long and narrow and curved backward like screws. Also, The back edges of its frill were extended into thin, flat spines that pointed backward. Styracosaurus reached lengths of about 5 meters and weighed almost 5 tons. So it was definitely no small dinosaur. It was also about the same height at the hips as the Triceratops, but it had a longer body and a shorter tail. Styracosaurus was definitely a plant eater. We know this because it had a beak like the Ornithischians, which were primarily herbivores. All right, so now we're going to look at a couple more of our favorite Ceratopsians. If you want us to do an entire episode on any of these dinosaurs, leave us a comment and let us know. Our next dinosaur is the Chasmosaurus. The name Chasmosaurus means a Greek word for wide-set horned face, and this is fitting because it had a pair of long, thin horns pointing up and out from above each eye socket. Unlike the Triceratops, its horns did not curve forward. The Chasmosaurus also had a frill around its head, but unlike the frills of the Triceratops and the Styracosaurus, the frills of the Chasmosaurus was relatively short and did not extend into spines. Instead, it had 4 holes on either side of its frill, creating a row of large openings along the back of its skull. The Chasmosaurus grew to lengths of about 4.5 meters and weighed almost 2 tons. It had a relatively short, bulky skull and a short, low-crested frill. It lived in what is now the western United States during the latter half of the Cretaceous period, from the late Santonian age until the end of the Maastrichtian. Our final dinosaur is the P. Tetraceratops. This is a newly discovered genus of dinosaur that contains one species, the P. perplexa. It was named by Wendy Ceratops in 2014. The name Tetraceratops means 4-horned face, and of course, this is because it had 4 horns growing from its head, one above each eye socket and one over each nostril. This is the only known ceratopsian with nostrils horns. Like the Chasmosaurus, the P. Tetraceratops had a short frill with 4 holes on each side. But unlike the Chasmosaurus, the front corners of its frill were drawn out into extensions. The P. Tetraceratops was about 3 meters long and weighed roughly 600 kilograms. It lived during the middle of the Cretaceous period in what is now North America. Well, that wraps up our list of favorite Ceratopsians. Do you have a favorite horned dinosaur? Let us know in the comments below. Thanks for coming along on this dinosaur train adventure. Remember to keep an open mind, and I'll see you later.